Welcome wherever you are. I want to take you through chemistry paper 3 practical the year 2016. This is the paper that was done in the year 2016. This year there was no titration, so there was a lot of information that the students were given. They were supposed to carry out this experiment, which had the even starch was there. This is how it was looking like. Because I'm not going to do this part, I'm going directly to qualitative analysis. So I want to let us look at the qualitative analysis part of it, because the other one we needed a student to follow instructions. So I'm here now. This is the qualitative. You are provided with solution G. So this year they were given a solution. We are used of solids. So you are provided with solution G. Carry out the following tests and record your observations and inferences in the spaces provided. So measure the pH of solution using 2 centimeters cube of solution G and a universal indicator paper. So what was the observation? The observation was the student got a pH of 10. A pH of 10. When you get a pH of 10, it means that it is a weakly alkaline. Weakly alkaline. This is not the correct spellings. Alkaline. Weakly alkaline or basic. Weakly basic. Others got a pH of 11, or 12. Both of them, they were supposed to score. If they wrote a correct inference, that is, one was a strongly basic stroke alkaline. So if you are given this and you are supposed to test for the pH, don't write a strong base or a weak base. No, you write weakly basic or strongly basic. Don't write weak acid or a weak base, or you don't write like that. To about 2 centimeters cube of G in a test tube, add dropwise dilute nitric 5 acid until no further change. Retain the mixture for use in test C Roman 1 to C Roman 2. So whenever you are adding any acid, whether it is nitric acid or hydrochloric acid, into a solution in a test tube, the first observation you are expecting is effervescence. So always remember that I am adding nitric acid or hydrochloric acid, an acid to a solution which is or a solid in a test tube, then you must expect effervescence from the first word go. So here we expect effervescence. So effervescence, it will either occur or it will not. For this one, effervescence occurred. Effervescence occurs. If you don't write effervescence, you can write fizzing. Fizzing occurs. So effervescence occurs. Whenever effervescence is occurring, it means in that solution there was a carbonate, a sulfite, or hydrogen carbonate ions. So we are used to the carbonate, the sulfite. You can also add hydrogen carbonate present. Very good. Next one, divide the mixture obtained in B above. Now we have this mixture. Divide the mixture obtained in above into 2 portions. we are going to divide this solution or mixture into two portions, and then to the first portion, add 3 drops of aqueous lead to nitrate. We know very well that lead is used to test for the sulfate, the sulfite, the carbonate, and the chloride, because all of these, they will form a white precipitate with it. So you need to know that all of these ions will form a white precipitate with lead. So you need to be sure. So what was the observation here? The observation is that a white precipitate is formed. A white precipitate is formed. So the answer here is the sulfate and the chloride present. The sulfate ions and the chloride ions present. Now the question which you may ask before you ask it, let me answer that. Why didn't I write the sulfite and the carbonate present? Because the carbonate and the sulfite and the carbonate, they form a white precipitate with lead. Why didn't I include them in this inference? First, you need to know that nitric acid was added and it was dropwise until no further change. It means that the acid that was added into this solution G was in excess. So some acid could have remained inside. So that acid that remained inside, if there was a carbonate and a sulfite, it reacted completely to form a colorless solution. And the colorless solution now does not contain the carbonate, does not contain the sulfite. Did you get what I've said? After adding nitric acid in solution G, the acid was in excess. It means the acid reacted with the carbonate and the sulfite completely, and there was no more carbonate and sulfite remaining inside there. Therefore, we cannot, if you include here, you will get 0, because you are right, that one is contradicting ions. Those are called contradicting inferences. Therefore, if you put them here, you contradict the one that are supposed to be there. Therefore, we included this one because this one already were eliminated from here. So that is how trick KCSE is a simple trick, and you are there. Therefore, and for now, you will not make the same mistake again. To the second portion, add 3 drops of aqueous barium nitrate. We are adding barium nitrate only into this portion here. Remember, this portion contains nitric acid inside. You should know, because the acid was in excess. So what we expect is white PPT. Now, let me take you back a little bit. Barium forms a white precipitate with sulfate. Barium sulfate is a white precipitate, therefore it forms with the sulfate, that is the sulfate, the sulfite, and the carbonate. So these 3 anions form a white precipitate with barium. Barium sulfate, barium sulfite, and barium carbonate. A white precipitate has formed, so we are supposed to include here sulfate, sulfite, and the carbonate present, right? But remember, the sulfate and the sulfite and the carbonate was removed here because of the acid which is inside. Because a carbonate and a sulfite will undergo neutralization reaction to form a colorless solution. A reaction we call neutralization. Therefore, if you include a sulfite here or a carbonate, that one is called contradiction or contradictory answers, and you will get nothing, 0. Therefore, the only answer here is the sulfate 2- present. Describe the test that you could carry out to if zinc 2 ions were present in solution G. So when we are testing for zinc, we use ammonia solution. You should know that. So we are supposed to describe a test. Already we have a description here. You can steal from up here. You can copy. So you will say to 2 centimeters cube of solution G, add ammonia solution, add ammonia dropwise until in excess, That is the test, the description of the test. So what expectation do you expect? The observation, expected observation is that white precipitate is formed which will dissolve in excess. So white PPT soluble in excess ammonia, ammonia. So by doing that, you have described and given the observation, the expected observation. Now the next question is that carry out the test to describe the test described in D above. So suppose you describe the test wrongly, even this question you will get it wrong. But if it is right like it is, then you are going to get the correct answer. So after carrying out the test, it was found out that no white PPT formed. So remember, this one, it was not the test. This one was a description. What do you expect? So here, since there is no white precipitate, it means that the zinc 2 ions are absent. They are absent. Yeah, they are absent. Number 3, you are provided with solid edge. Carry out the following tests and record your observations, inferences in the spaces provided. Like I've also advised, is that you need to know whether this solid is an organic compound or it is an inorganic compound. Therefore, how do you know that? You first have to read through the reagent that I used. The first reagent here we have is sodium hydrogen carbonate. If you move down, we go and we find sodium hydrogen carbonate repeated, and then we have bromine water. So you see we have bromine water. That simply tells you that this compound, this what we are doing now with, is organic chemistry or organic qualitative analysis. Therefore, you don't have to make a mistake of writing cations and anions in organic chemistry. Very correct. You need to know that. So let us start from number 3 there. Place all solid H in a boiling tube. Add about 10 centimeters of distilled water and shake the mixture thoroughly. So we want to find out whether this solid is dissolving in water or it is not dissolving in water. So the solid dissolves in water, and dissolves to form a colorless solution. So if it dissolves to form a colorless, and we have already identified that we are in organic chemistry, then it means that the compound in question is a polar organic compound. It is a polar organic compound present. A substance which dissolves in water, it is called polar, and the one that does not dissolve is called non-polar. For this one, it is dissolving in water. Water is polar, therefore that compound is polar. To about 2 centimeters of the mixture in a test tube, add about a half of the solid sodium hydrogen carbonate. You must be very careful. You have been told a half. So it means you need to remain another half. If you use all of it, KCSE doesn't provide extra. Therefore, you should know. NEC does not provide any extra. You should be aware of that. To about this now, what we are adding sodium hydrogen. Whenever we are adding sodium hydrogen carbonate or sodium carbonate, we are expecting effervescence. If that solution contained is an acid, then we will receive effervescence. So for this one, there was no effervescence. Or there is no fizzing. These and these are okay, no fizzing. So it means the organic acids are not there. So we use RCOOH to represent organic acids. So it means it is absent. It is absent because there is no effervescence. It is absent. To the remaining amount of the mixture of H in the boiling tube, add about 10 centimeters of dilute hydrochloric acid. Shake thoroughly, then filter the mixture. Wash the residue with distilled water. Dry the residue using filter papers. Use the residue to test 1, 2, and Roman 3 below. So place about the 1/3 of the residue in a test tube. Add about 10 centimeters cube of distilled water and warm the mixture. To the warm mixture, add the remaining amount of sodium hydrogen carbonate. Practical is just following instructions. If you are asked to add 10 centimeters, you add. You warm. To the mixture, add sodium hydrogen carbonate. Just following instructions, you will enjoy chemistry. So here, we are adding sodium hydrogen carbonate, therefore we expect effervescence or no effervescence. For this one, there was effervescence. There was effervescence. So if there is effervescence, it means the is present. So you may ask, why did we write here absent and here we are writing present? There are so many things we have done here, so you don't need to worry. What will give you this answer is the observation. If effervescence occurs, then this one is present. If it does not, this one is absent. As simple as that. So as well as you can write fizzing occurs. If effervescence is the spellings will be difficult for you, you can write fizzing occurs. To about 1/3 of the residue in the test tube, add about 5 centimeters of distilled water. Shake the mixture and then add 3 drops of bromine water. Whenever we are using bromine water, we expect bromine water, the color to change from yellow to colorless. Yellow to colorless, we call it decolorization. So we say when bromine, which is yellow, changes to colorless, we say that bromine has been decolorized. So if it is not decolorized, then we say bromine is not decolorized, or the yellow color of bromine is retained, remains yellow. So what was the observation here is that bromine water is not decolorized, meaning that the color of bromine water did not change from yellow to colorless. That is what it means. So if it did not change, or you can say the color of bromine, the yellow color of bromine water is retained. Retained, it means it remained yellow. So if it is so happens, what is the inference? It means that there is no a double bond, there is no triple bond, because those are the saturated and unsaturated organic compounds which decolorize bromine water. So it means that the double bond or the triple bond is absent. Is absent. If it was present, this one will be decolorized. To the remaining amount of the residue in a boiling tube, add about 10 centimeters cube of distilled water, about 5 centimeters of dilute sulfuric acid, and then about 5 centimeters of ethanol. Warm the mixture. Here we have a pleasant smell. So a pleasant smell was produced, or a fruit smell. So if a fruit smell is produced like that pleasant smell, then it means that the ROOH is also present. Why are we saying that this alkanoic acid is present? Because we know an alkanoic acid plus ethanol in the presence of dilute sulfuric acid, we form an ester. Esterification. Esters are very pleasant smelling organic compounds. Therefore, we say that the alkanoic acid is present because alkanoic acid plus ethanol plus this, and then you warm, you form an ester. Ester formation is called esterification, and the compound formed is a very sweet, pleasant smelling, not sweet, pleasant. So it is very pleasant. Thank you, and I have reached the end, the last page. Thank you very much.